Introduction to Debugging. A quick introduction of the main concepts presented in this lecture. Debugging is the process of finding and resolving of defects that prevent the correct operation of computer software or hardware systems. Debugging tends to be harder as systems become larger or more complicated. Specialized tools can be used to make debugging more efficient. Atmel Studio is a rich, integrated development environment for developing applications for Atmel's microcontrollers. It is based on Microsoft's Visual Studio and works only on Windows computers. It can also be used with the Arduino and can replace the basic Arduino IDE. Atmel Studio offers sophisticated device and library support, an advanced editor, a solution explorer, advanced hardware debugging capabilities, and can be extended via plugins. Hi, in this and in the next few lectures, I'll discuss Atmel's Studio application. Atmel Studio is a full-blown integrated development environment. It is based on Microsoft's Visual Studio and the .NET framework, and as a result is only available on Windows computers. And it gives you a full modern environment in which you can develop applications for Atmel's microcontrollers. In the next few lectures, I will focus on a particular part of Atmel Studio's capabilities, which has to do with its ability to debug applications that are running inside an Atmel microcontroller. What I mean by that is this. People developing applications on the Arduino are used to doing debugging, which means are used to trying to figure out where problems are with sketches by using little print statements, like in this example here. So I've got a serial print statement. It just prints out a little number, and then I use the serial monitor to try and get some idea of what is happening inside my sketch as it is executing in the microcontroller. And based on these numbers or whatever else I'd like to print out to the serial monitor, I try to figure out if there's a problem with the way that my sketch is working and get some clues that may help me fix the problem, if there is a problem at all. And that's as far as debugging with the traditional Arduino IDE goes. I have no way of inspecting things such as specific memory locations, for example, or using some typical features that you find in full integrated development environments, such as the ability to set breakpoints and to inspect variables as they are changing on the fly inside the microcontroller, and even make changes to those variables and restart a sketch. So with the normal Arduino integrated development environment, the Arduino IDE, I can't really do any of the things that I would expect a full-blown modern integrated development environment to be able to do. So I will show you how you can use Atmel Studio to do all of these things that we take for granted in terms of debugging an application that is running live inside the microcontroller. Okay, so I wanted to show you, first of all, on the Atmel website, that Atmel offers a lot of different products, and one of them is the Atmel Studio. Atmel Studio is a free application to download and install on your Windows machine. In my case, I'll be running this application inside a Windows virtual machine on my Mac computer. The example that I'll use is based on my Arduino Zero here. The nice thing about the Zero is that it's got a chip here. It's an embedded debugger chip, EDBG, and this chip is a device that allows you to inspect the execution of a sketch running inside the SUMD microcontroller here. So this chip here is a debugger, and this chip here is the microcontroller. Give you a closer look. Okay, so the debugger and the microcontroller. The debugger is the hardware component on this board that is interacting with the Atmel Studio application. So it is responsible for basically controlling the execution of the sketch inside the microcontroller and then reporting the various statuses or making changes to memory locations inside the chip as I specify them in the IDE. So this is just a really, so the zero I mean by that, is a really nice board among other things because it has this chip that allows me to do live debugging with Atmel Studio. If you have a microcontroller that doesn't have this built-in capability to do debugging, then what you can do is you can use an external debugger, like for example this Atmel ICE device, which allows you to hook into a great variety of microcontrollers and debug them in pretty much the same way as what I'm going to show you. With the Atmel ICE debugger, of course, you get full compatibility with Atmel Studio, and you can debug all sorts of Atmel microcontrollers with it. So you've got your AVRs, your 8-bit AVRs like the X Mega, on which the Arduino Uno is based, the AVRs and the SUMD microcontrollers like the ones in the Zero Arduino. And they support different interfaces by which you can connect this debugger to your target microcontroller. So that's something to consider if you want to do debugging in something other than the Arduino Zero. So in the next lecture, I'll show you how to install Atmel Studio on your computer, and then we'll start the demonstration once that is done.